Okay, I'm trying to hack this system because sometimes it doesn't let me use Smart Notes and my screencasting software, which is a bit of a bummer for us. But let's take a look at this problem. It says find the domain of the composition. Now, when we're finding the domain, we need to do three things. Okay, it starts with identifying the domain of the interior function. Sorry, let me get a pen here. Okay. The domain of the interior function, which in this case is g of x, right? That's the gatekeeper. I have to be able to use, or I'm only going to be able to use the numbers that work in g from the get-go, right? So I set this greater than or equal to 0. I can't take the square root of negative numbers. So we get x has to be greater than or equal to -7. So right now, that's the biggest my domain could possibly be, okay? Now, because the outputs from G are going into F, I have to figure out what the domain of F is as well. Oh no, where'd my pen go? Bear with me here. A couple of technical glitches. Hopefully I can get this to work. Okay. So I have to worry about the domain of F as well. Now here, oh, you are a stinker. Let's see here. Let's see if I can do it this way. I've got x cubed minus 2x squared minus 8x, and that's in the denominator, right? So I can't let that equal 0, right? So we can never let the denominator of a fraction equal 0. So the numbers that do that will have to exclude from the domain of f, not the domain of the composition, the domain of f. Keep that in mind, okay? And when we get a statement like this, we factor the expression that's given to us that's set not equal to 0. So we have a common factor of x. We'll factor that out. And then this even degree trinomial can be factored into binomials, we hope. So we get x, oops, not x squared. Let's see if I can erase that. Ooh, that's going to be a problem. I'm just going to cross this out. It's not x squared, it's x, right? Sorry. And this is x. Now here I need two numbers that multiply to be -8 and add to be +2. We should know that those are +2 and -4, and we cannot let this entire product equal 0. So we have three factors in this product. We have x plus 2, we have x minus 4. We cannot let x equal 0. So what? If this is 0, the entire product is 0. So we have to exclude 0. If x here is -2, this factor is 0, and the entire product is 0, right? So we also have to exclude -2. And then finally here, if this is 4, this entire factor equals 4. This entire product would be, or excuse me, if this is 4, this entire factor equals 0. The entire product equals 0, so I can't let x equal 4 as well. So these are the values of the domain of x that, or of f, that I have to exclude. Now, these are not values that I have to exclude from the domain of the composition. These are values that I cannot plug in to this function. But remember that the numbers that are being plugged in here to this entire thing are the numbers that are coming out of this. So in other words, to finish this problem off, I have to set up 3 inequalities, and in the interest of time, we probably won't do all of them, but I have to say, okay, this square root of x plus 7 can't equal 0. Because if I plug a number in here that gives me a value of 0, that 0 is then going into this for every value of x. And then once this is 0, this is 0, and this is 0, the entire denominator is 0, the whole thing falls apart. So basically, in the interest of saving time here, I'm going to cut this short. Once we know what the domain is of the interior function, and we know what the domain is of the exterior function, we set the interior function not equal to these values, solving each one. So if I square this and subtract 7, it says, okay, x can't equal -7. Let's see if this will, look at that. Then I have x plus 7 cannot equal -2. Square both sides and subtract, right? Are we ever going to get negative 2 from this? Right? If we square both sides and we subtract 7, we get x cannot equal negative 3. But because this is negative 2 and because this is a function, and this is getting quirky, but because we have a radical in the function, we don't even assume that negative 2 can be an output. So we're not even looking at this. We only accept the positive outputs of radicals when they're written as part of a function. We talked about the semantics behind that earlier. So we don't need to worry about that. And then lastly, sorry, let me get my pen back. Hopefully this continues to work. Got my pen back. Nice. We have the square root of x plus 7 cannot equal 4. Square both sides, subtract 7. We get x cannot equal 9. A value of 9 here gives me 16. The square root of 16 would equal 4, and I'm not supposed to let it equal 4 because of these values up here. So all in all, we have this value that we have to exclude because it produces 0. We have this value which we have to exclude because it produces 4, and we have the initial inequality saying the x values have to be greater than or equal to negative 7. That would be the entire domain of this function. Sorry. Oops. Oh gosh.